So, good afternoon to viewers. This is my internship Emertxe internship project submission report, and this belongs to IoT. This internship is based on IoT. So we had done IoT automation, home, and in this internship we had covered so many topics. Let's see the topics we had covered in internship are the basics of C and C++ in C, variables, data types, operators, arrays, pointers, and functions. At the same time, when it comes to IoT, the definition of IoT, the need of IoT, and general components of IoT, IoT challenges, and IoT architecture. Topics we covered in internship are embedded systems and categories of embedded systems, general components of embedded systems, project requirements, the how to operate project through Blink IoT app on mobile, and at last we had discussed about Disha workshop for IoT intents. So if you take variables are used to store data to assign a value to variable, and a variable is a basic programming variable is a basic program. And if you take data types refer to the type of data in which variable is going to store. We take in C, we are having mainly primarily four data types, which are int, float, character, and double. And int stores integer values. At the same time, float stores pointer values, pointing decimal values, and character stores letters, which are single letters. And double is a 8-byte size data type, which stores fractional values of large numbers. And operators, if you take, we are having four operators primarily: arithmetic, relational, logical, and bitwise operators. And if you take arithmetic operators are used to perform arithmetic operations between two numbers. Here is an example, simple example, which performs arithmetic operations are called addition and subtraction between two numbers that we assign the variables a and b. And next, coming to relational operators. Relational operators are used to provide a relation between two numbers. The relation operators will return true if given relation is true, or false if given relation is false. So if you take this is an example. And next, logical operators. Logical operators are used to check the logical relationship between two values. Same here, logical operators, if you consider, we are having logical and, logical or, and logical not operator. Logical and operators will return true when all the given conditions are true. At the same time, when logical or operator returns true when at least one condition is true among given conditions. Not is an operator which is performed on unary variable, that is which returns opposite to the given statement. Here is an example. At the same time, bitwise operators. If you take bitwise operators will perform operation according to bitwise manipulation. We are having bitwise. If you take bitwise AND operator, it takes 2 bits and perform AND operation, and result of AND operation is 1 when 2 bits are 1, and 0 when 1 or 2 bits are 0. And bitwise OR operator also takes 2 bits to perform its OR operation. The result of bitwise OR operator is 1 when one of the 2 bits is 1, and 0 when two are 0. Bitwise NOT operator. Bitwise NOT is an unary operator which takes only 1 bit to perform its operation. So result of bitwise NOT operator is 0 when the given bit is 1, and 1 when the bit is 0. Here you take an example. For example, if we take 7 as an example, the binary representation of 7 is 0 1 1 1. When we apply bitwise NOT operator to 7, we get 1 0 0 0, which is numerically equivalent to 8. So NOT of 7 is equals to 8 according to bitwise NOT operator. So similarly, bitwise XOR operation will perform XOR operation between 2 bits, which means that the bitwise XOR operator will take 2 bits to perform its operation. Result of bitwise XOR operation is 1. when two bits are different, either it could be 0 1 or 1 0, and 0 when the two bits are same, either it is 0 0 or 1 1. If you take, we here we performed XOR operation between 7 and 4, so the resultant is 3, it is equivalent to 3. So if you take bitwise shift operators, there are two types of bitwise shift operators are there. They are bitwise right shift operator and bitwise left shift operator. If you take bitwise left shift operator is equivalent to multiplication of 2 to the power of right operand. Here is an example which gives an idea. At the same time, bitwise right shift operator is equivalent to division by the 2 to the power of right operand. Here is an example. And then coming to arrays. Arrays are used to store multiple values in a single variable. Instead of declaring separate variables for each value, arrays will store memory values in continuous memory locations. To create an array, we have to define the data type and specify the name of array. Then only we are able to allow the array to store variables in memory locations. The lowest address corresponds to the first element and highest address corresponds to the last element. Here is an example. We had declared int my numbers, and we had assigned four elements in an array in which index is starting from 0 to 3. 0 refers to 25 and 3 refers to 100. When it comes to pointers, a pointer is a variable that stores the memory address of another variable as its value. And here is an example. Syntax of a pointer is we have to represent the data type, and this star mark which represents it is pointer and variable name. Here if you take an example, int is a data type which we assigned, and here variable name is my age. So it will store the 21 as my age. So if you comes to functions, functions are basically a set of instructions that it takes two inputs to perform some computation and produces output. If you see syntax, first it returns type and function name and it takes set of inputs. So what is the need to use functions in C means reusability and abstraction are the two main reasons that should be considerable. Reusability means we should declare a function in the beginning of program, and we are able to use the function in the entire program wherever we want. This is an example of functions. And storage classes. C is having mainly four storage classes. They are auto, extern, static, and register storage class. And if you take, and then coming to Internet of Things, IoT. The internship deals with Internet of Things. IoT can be defined as the network of physical objects that contain embedded technology to communicate and interact with their internal states or the external environment. IoT not only makes the effortless work, but also secures us. IoT devices to internet after collecting data from devising systems and humans to build their better understanding of world among us. So why we do prefer IoT means IoT will be effortless and makes easier to use things or devices. If you take example watches, smart cars and mobiles, etc. So today in world 13.8 billion IoT devices are being in usage. So they are unique objects that are connected to internet. Why IoT means they are used for bidirectional communication. Large amount of complex data can be flows. Ability to track and monitor things, lighten the work load with automation, better quality of life. It increases efficiency by saving money and resources, which is important to consider. Things that are making IoT to grow faster in today's IoT is an actually now IoT is at inflation point, which means it is growing very rapidly day to day. Hardware is getting cheaper, by which investment will get reduced. So many prefer to IoT, and connectivity is getting proliferating. So today things IoT, Internet things are being increasing very rapidly, multiplying by every day. So, and another reason is software is getting too faster, and its scale and flexibility makes some IoT to grow faster and make an important role. And general technical requirements are volumes of data, end-to-end integration, and vague security requirements. IoT challenges. So, if we consider the challenges in IoT, then addressing scale, connectivity, data volume, device size, huge cloud storage comes into the picture. So, advantages and disadvantages of IoT are the advantages of IoT are cost reduction. The cost will be reduced, which makes people to use them easily. Efficiency and productivity. So, efficiency and productivity is the main factor which plays the role of IoT for longer time, and business opportunities also increase by the IoT, and mobility and agility. So mobility, the IoT can be movable from one place to another place with humans itself. So it is very easy to use IoT. At the same time, if we take disadvantages of IoT, safety. If we want to dealing with a large amount of complex data, then safety should be somewhat hard to hold the safety, and complexity. Complexity also involves in this process, and IoT based. This is the project IoT based home automation system. Tools that are required are Arduino, IDE, Piximlab, and Blink app and IoT mobile application. So we had performed garden lights control system and temperature control system, water inlet and outlet valve control system. So temperature control system is mainly consist of LM35 temperature sensor, a heater, cooler, which are giving their own activities to perform. And similarly, water tank inlet and outlet valve is having garden lights within their own parts. So if you take IoT, there are four stages in IoT architecture primarily, which are data should be gathered, and data transmission, data processing, application layer. So from stage to stage, the IoT role should be increased. Data flow. This represents the architecture of IoT. Next comes embedded systems. Embedded systems. So embedded systems can easily defined as the combination of software and hardware which are intended to do a specific task can be embedded systems. So the factors that helped us to decide a system is an whether a embedded system or not, are either it is a combination of both hardware or software, and either it is performing a specific task or not. If yes, then it is an embedded system. If you take an example like TV, webcam, laptops, routers, missiles, and micro ovens, washing machines, refrigerators, etc. Requirements. So the requirements of embedded systems are mainly sensor. Sensor helps us to detect the motion of an object, and relay, which will make the circuit to make and break, which are refers to on and off. The timer to know how much time the task is need to be performed, and comparator, and security, safety, reliability, usability, characteristics of embedded systems. Real-time operation and manufacturing cost. So if manufacturing cost is low, then its usage will be increased in the market. And processor and memory, which are having variations in processor and memory. Based on processor and memory, the embedded systems are getting advanced and sophisticated function, tight design constraint. So its design should be perfect, then only it is safety to use it. And categories of embedded systems are standalone embedded systems. So generally, these kind of embedded systems are mostly independent, which means that they are able to take their decision independently. For example, self-driven cars. Self-driven cars should drive themselves. Machines should drive themselves in a road. even though if there isn't traffic or something turns turns on road, anything, the car should self drive itself. We just need there is to sit there only. And network embedded systems, when one or more embedded systems are connected together to perform a task, then that type of embedded systems are known as embedded systems, network embedded systems. And real-time embedded systems, which means they are able to complete a task within the deadline. The deadline means time. The time refers to task to be completed. The time should be in either nanoseconds, microseconds, or picoseconds. For example, airbag systems. The airbag systems are comes under real-time embedded systems. And next, mobility of embedded systems. Mobility of embedded systems. They are able to move from one place to another place. For example, smartwatches. If we take smartwatches on our wrist, it will move with us wherever we go. It come with us. So these kind of instruments and applications are comes under mobility embedded systems. And general components of embedded systems are microcontroller and system on chip, which is SoC, and microprocessor. A microcontroller means if you take a microcontroller, all peripherals of a microcontroller means processor, memory, timers are embedded on a single IC. Microcontroller size is generally small in size. And if you take microprocessor, all peripherals of microprocessors are integrated on different ICs. So IC means integrated circuits. So generally microprocessor is large in size. If you take system on chip, if more than one microprocessor and microcontroller are being integrated on single IC, then that is system on chip. That is SoC. If you take memory, there are different types of memories are there. RAM, which is random access memory. RAM is a volatile memory, which means the data will be erased after power cuts. And ROM, which is read-only memory, is a non-volatile memory which stores the data onto it, and we are not allowed to rewrite it. OTP, one-time programmable memories. These are one-time programmable memories. At the same time, if you take UV-ROM or EPROM, EPROM is electrically programmable ROM, which is capable to provide the feature of rewriting of data. And then masked ROM to store that important data which do not to get corrupted, which means the data should not get corrupted, means debugs or something errors should not get into the data. This kind of data is stored in masked ROM. Example, manufacturing ROM. And EPROM, NAND and NOR flash memories are in kind of EPROM. And if you take project requirements, garden lights control, this required LED, light emitting diode, and LDR, light dependent resistor. Uh, temperature control system, which is which requires a temperature sensor, that is LM35 sensor, and heater, cooler, IoT app, Blink IoT app on mobile to control the temperature control system. And water tank, which is serial tank, CLCD. Tools that are required for this are a development, Arduino IDE to write the code, and simulating tool, that is PiximLab. Whatever the code we had written in Arduino IDE, that should be simulated in PiximLab. And an Arduino UNO board is required. And IoT project requirements are input and output pins in PiximLab. These are if you take input pins are switches and outputs are LEDs on PiximLab. Analog pins, these are used to connect analog inputs and digital inputs also. Built-in LED, and we want a built-in LED, reset pin, USB, and clock speed. The reasons that LED is most oftenly used are: LED is a simple device in which most of the embedded systems applications are used as applications as feedback, and LEDs are work just like diodes. For example, if we take the reasons to use LEDs, the low energy consumption, longer life, smaller size, faster switching, or made them to use in white fields. For example, home lighting, system and remote controllers, surveillance, displays, etc. So LED interface with Arduino board. An LED can be interfaced with Arduino circuit and based on two ways in which forward bias and reverse bias. If we take forward bias, the LED is in on, and in reverse bias, the LED is off. LEDs are small, powerful lights that are used in different applications. And go on to interfacing of LED with Arduino. This is a resistor and this is an LED Arduino board in which LED is connected to Arduino board along with the resistor, along with the resistor and interfacing of microcontroller with Arduino. A microcontroller can be also interfaced with Arduino in two circuits. Number one is sourcing circuit and sinking circuit. A resistor is being used in these circuits, and a resistor is a current limiting resistor. In sourcing circuit, for one LED will be on and for zero LED will be off. In sinking circuit, it will be vice versa. The description is in sourcing circuit, the LED will be grounded along with the resistor. In sinking circuit, LED will be connected to power supply VDD. It may be of 5 volts. Sinking circuit will absorb the current and sourcing circuit will be the sourcing the elements and LED will be output device. And project requirements are CLCD, that is a character liquid crystal display, is used to ASCII characters and some customizations are possible in CLCD. Applications of CLCD is liquid thermometers. In liquid thermometers, we had using CLCD. Next one is analog input. Analog input are very important peripherals because we are giving analog inputs for embedded systems to perform its real-time operation. LM35 heater and cooler temperature sensor are analogous in nature, which their values are varying continuously, so that they are called as analogous in nature. Controllers will only understand digital signals, so real-time linear values are converted into digital form and given to them as inputs. Given to them as inputs. In Arduino boards, we are having analog inputs from which are known as generally input and output pins from A0 to A5, total 6 pins. These are called as analog channels also. And if we take a Arduino LM35 sensor, this device is a temperature measuring device having analog output voltage proportional to temperature. It provides an output voltage in centigrades. Sensitivity rises up to 1 degree for every 10 millivolts. So if you want to read analog read from 0 to 1023 units will be there.